welcome back to the channel. So today in this video lecture, continuing in the Trie series, we'll be solving this problem, maximum XOR of two numbers in an array. So basically we're given an integer array nums. We have to return the maximum result of nums I XOR nums j, where I and j lies between 0 and n minus 1. These are the indices of the integers which are there in the array. And we want to pick two integers out of the array, not necessarily distinct, such that the XOR of those two integers gives me the maximum possible value for that particular array. Okay, so let's take an example to understand it better. Let's say we have this array 3, 10, 5, 25, 2, 8, and the maximum result is 5 XOR 25, which is 28. So 5 XOR 25, which is 28, and that's the answer, 28. Fine. So let's see how we can solve this problem. And one of the naive ways to solve this problem is easy. That is, just use brute force. Use two nested loops. Start one pointer from the very first integer 3 and try to XOR it with the rest of the numbers. So 3 XOR 10, 3 XOR 5, 3 XOR 25, 3 XOR 2, 3 XOR 8, and take maximum of these results. Okay, and repeat the process for every single integer of the array. For 10, try to club it with 5, 25, 2, 8, and then same goes for 5, 25, 2 and 8. Okay, and just find the maximum of these numbers, and that will give me my answer. Okay, so and the time complexity for this solution would be big of n square, where the very first iteration iterates over the array, and the second iteration which starts from the right next element on which I am currently standing. Let's say I'm standing on 3, and the nested loop starts from 10, which iterates over rest of the elements and try to club it with 3, and the time complexity would be big of n square. Now, what is the space complexity? Obviously it will be constant because I am not using any extra space. This is just a brute force solution, and let's say if it works or not. We can see that the constraints of the problem are the maximum length of the nums array goes up to 2 into 10 raised to the power 5. That is, if n is of the order 10 raised to the power 5, then the operations would be this. And we know that in 1 second we have 10 raised to the power 8 operations, while giving me 100 seconds to execute the code over these type of constraints. Okay, that means this solution is not optimal because it would take 100 seconds to execute, and this is out of the time limit. So this solution is suboptimal, so we have to devise a better solution. Let's see how we can do that. Now, since we are learning about tries, obviously the solution which this problem has consists of tries. So what I'm going to do is I'm simply using tries, and I'm going to push all of these integers into the trie. How? Let's see that. We know that the logic is simple. We know that the maximum XOR for any number, like take this number 3, 10, the maximum XOR, the maximum XOR is for the numbers which has alternate bits at these positions. Like for this case we had 5 and 25. Why? Because let's write 5 in the binary format. It would be 0, 1, 0, 1. And let's write 25. It would be 1, which is 16 plus 8, then 1. Okay, now we can see that here we have 0, 1, 0, 1, and if we XOR them 1, 1, 0, 0. So we had 3 positions where we had alternate bits. Okay, we had alternate bits, and that's why it gave me the largest number, which is 28. So try to find those two numbers in the array which has maximum number of alternate bits towards the left side. Okay, that's my purpose, and that means we have to keep track of the bits of these numbers. We have to perform operations over the bits. To do so, we're gonna store the binary numbers, the binary formats of these numbers into the trie. Let's see how we can do that. You got the logic. What we want to do, we want to pick two numbers out of these given set of numbers, such that those two numbers have the maximum number of alternate bits, so that when we XOR those numbers, the resultant numbers is a maximum number. So let's see how we can do that using tries. So let's first write the binary format of these numbers. So for 3, we're gonna write 0 0 1 1. So 16 8 4 2 1. Then for 10 it would be 16 8 4 2 1. Then for 5 it would be 16 8 4 2 1. For 25 it would be 16 8 4 2 1. Okay, then for 2 it would be 16 8 4 2 1. Then for 8 it would be 16 8 4 2 1. Now this is the binary format of these numbers. So let's see how we can push them into the trie. So we take a trie, and from the trie we start pushing this number. So start from this bit, which is the very first bit, and we can say it is the 31st bit. So although it is not the 31st bit, but we will start pushing the bits from this bit. Okay, so let's push it. I am doing this just because all of the bits which lies towards left of it, they are also 0, and there's no meaning pushing those bits into the trie. So that's why I'll start from here. So let's start from here. We try to push it into the trie. Push 0 here. Okay, so push 0, then move here again, push 0. So what I'm going to do is start from root. I'm going to check if we have a child which is 0, which points to 0. No, we don't have any child. That means we create a child which points to 0, and that's what I'm doing it. We have a pointer which points to 0, and this node again points to 0 because that's what I want to store here. Then we have 0 again. We know how to implement tries for a series of numbers. Now here, this 0 points to this one, so put 1 here. Finally we have one more 1, so we have 1 here. Fine, so we have inserted this number into the trie. Let's start inserting this one. Start from this number. Do we have a child which is 0? Yes, we have child here. Do we have a child for this 0 which is 1? No, so let's create it. Do we have a child for 1? No, so we have to create all of the other numbers as the child nodes. Now this is also done. Let's move here. Do we have 0 as a child of root? Yes, we have. Do we have 0 as a child? Yes, we have. Do we have 1 as a child for this node? No, so let's push it. Then we have 0, then we have 1. So this is done. Let's push it. Let's push this number. Do we have 1 as a child for root node? No, we don't have. So we create. Do we have 1? No. Push all of the bits into the trie, creating new nodes subsequently, and this is done. Let's push this one. Do we have 0? Yes, we have 0 as the child of root node. Do we have 0 as the subsequent child? Yes. Do we have 0 as a subsequent child? Yes. Do we have 1? Yes. Do we have 0? No. So we create 0 here. This is done. Let's push this one. Do we have 0 as a child? Yes. Do we have 1? Yes. Do we have 0? Yes. Do we have 0 again? No. So we create 0. Do we have 0? Okay, 0, 1, then 0, then 0, and then 0 again. Fine. So in this fashion we have our trie prepared. So let's start from this root node, and from this root node, now we know that into this trie I have pushed all the binary numbers. I have pushed all of the numbers which we were given in the problem statement. So the next step is I try to find two numbers which which gives me the maximum XOR. So that means pick every single number from these numbers. So pick this one and try to XOR it with alternate with the number which has a maximum number of alternate bits. Like start from this number. This is basically 0 0 0 1 1. Fine. So what I'm gonna do is I'm gonna search into this trie starting from the very first bit here. I'm gonna put a pointer here, and for this pointer, for this bit which is 0, I'm gonna find a child for root node which is 1, because 0 XOR 1 gives me 1, and I want to maximize these number of ones in my final answer. So check if we have 1 here as a child for root node. Yes, we have. So move here. Okay. Now that means add 1 into the answer. Add the corresponding. So this is a 0 1 2 3 4. So it is basically 16. So add 16 into the answer, because a set bit corresponding to this position gives me a 16 as in the decimal number. So let's move to the next. It is 0. Do we have a child for this node which gives me 1? Yes, we have a child which is 1 here. That means again add 8 into the answer. Then move to this bit and check if we have a child which is 1. No, we don't have. If we do not have, then XOR it with 0. So it will give me 0. So we have the number till now is 1 1, the resultant number basically 1 1 0. Now move to this one 1. I want to find an alternate bit, that is I want to find a bit which is 0. Do we have a 0 bit as the child node for this one? Yes, we have here. That means this will give me 1, and add 8 4 2 1, sorry, 16 8 4 2. So add 2 here. Now move here. It is 1. So do we have a child node for this node which is 0? No, we do not have. We have 1 here. Okay. That means just XOR it with 1. So it will give me 0. So it will give me 0. So it will give me 16 plus 8, 24 plus 2, that is 26. Okay, so that's the answer which I have. Okay. If I basically try to XOR this number with the number which is constituted by this path. Fine. So this was basically 3. Now let's move to the next number, which is this one, which is 0 0 1 0 1 0. So I've got the maximum number which I have got till now is 26. So let's write it over here. So let's move to this one, which is 0 1 0 1 0. Okay. So let's start from the very first bit, which is this one, and start from the root node. Do we have a child which is 1 for this root node? Yes, we have 1 here. So put 1 here. No, do not put 1. Put the corresponding decimal number, which will be 0 1 2. It would be 16. So add 16 into the answer, because 1 XOR 0 will give me 1. So the result, let's write the resultant number over here. It would be 1. The resultant number would be 1. Let's move to the next bit, which is 1. Do we have a child node which is 0? No, we do not have. So let's XOR it with 1. So we XOR it with 1, and it will give me 0. 1 XOR 1 is 0. So we add 0. Now let's move to the next bit, which is 0. Do we have 0 as the child node for this node? Yes, we have 0 here. That means, okay, I want to find 1 because I found 0 here. Do we have a child which is 1? No, we do not have. So that means again we have 0. Add 0. Move to the next bit, which is 1. Do we have a child which is 0? Because I have 1, I want to find the alternate bit. Yes, I have it. That means 1 XOR 0 will give me 1. So put 16 8 4 2. Put 2 here. Then I have 0 here. So 0 XOR 1 will give me 1. Okay, so it will give me 1. So we have 1 here. So 16, 8, 4, 2, 1. So this is going to give me 19 as my answer. Okay, fine. So that's the thing. The second number is 19. So let's try with the third number, which is okay. So let's try with this number, which is I'm done with this. I'm done with this. Let's try with this number, which is 0, 0, 1, 0, 1. So let's start from the very first bit. So 0. Do we have a child node for the root node, which is 1? Yes. That would give me 1 as a resultant number, as a resultant bit for this corresponding position. And I'm going to add 16 here. Then move to this bit, which is 0. Do we have 1 as a child node? Yes, we have 1 as a child node for this. So that would give me 8 as well. So we'll have 1 here. So then we move to this one. Do we have 1 as the child node for this? No. Sorry, do we have 0 as the child node for this? Yes, we have 0 here. That would give me 4 here. Now move here. Do we have 1 as the child node for this? Yes. No, we do not have 1. So add 0. Do we have 0 for this node as a child node for the corresponding node here? Yes. No, I do not have 0. So again add 60 plus 8, 24 is plus 4 is 28. So that is 28. So if I XOR this number, which is 842 16, 8, 4 to 5 with this number, which is basically 25, because 16 plus 4 16 plus 8 is 24, 24 plus 1 is 25. That is going to give me 28. So let's check for the next number. Which is this one. So 1 1 0 0 1 1 0 0 1. Okay, so let's start with this number and let's start from the root node. So let's pick this bit. Do we have a child node for the root node, which is 1, which is 0? Yes, here. So XOR it with this node and it will give me 16. Like in the resultant number, I'll have 1. Then let's see here. 1, do I have a child node for this node, which is 0? Yes, I have 0 here. So add the corresponding number, because 1 XOR 0 will give me 1 in the resultant number. So add 8 here. Now move to 0. Do I have 1 as the child node for this one? Yes, I have 1 here. So add 4 again. Add 4 here. Okay. Because I've got 0, I've got 0, then I've got 1 as well. So I'm following this path. Now move to the next bit, which is this. Do I have a child which is 1? No, I do not have. So club it with 0. It is going to give me 0. Now I move to 1. Do I have a child which is 0? No. So club it with 1. So it will give. So this is again going to give me 28. So if I club this number, which is 16 plus 8, that is 24, 25, with this number, which is 00101, which is again, I think it's 5. Okay, it's 5. Then it is going to give me 28. So it's again other way around. I am in the previous case I was calculating 5 XOR 25. In this I'm calculating 25 XOR 5. It is same case. Now let's move to the next number, which is this one. Okay, so 0 0 0 0 1 0. So let's start from 0. Do I have a child node for root node which is 1? Yes. Do I have a child node? So that will give me like 16. Add 16 to the answer. So now move to the next bit, which is 0. So do I have a child node which is 1? Yes, it is here. Then move to this bit. Do I have a child which is 1? No. So For this one add 8 and for this add 0. Do I have a child which is 1? No. Add 0. Again 0. Do I have a child which is 1? Yes. Add 1. So it is going to give me 25. So let's put 25 in the list. And let's move to the next integer. So you got the idea what we are trying to do here. We just builded a trie, and then I am picking up every number from the array and I am trying to match it. I'm simply trying to XOR it with the most appropriate number in the trie which we have built it over the same numbers from the array. Now here pick this number, start from 0. Do I have a child node which is 1? Yes. So add 16 plus move here. Do I have a child node which is 0? No. 0 plus. Do I have a child node which is 1? No. Do I have a child node which is 1? No. Do I have a child node which is 1? Yes. So it will give me 17. So put 17 here. So we are done with all of these numbers, and I have tried to club it with I have tried to XOR every single number with the most appropriate number. Fine. So out of this list, the maximum number is 28, and this corresponds to the case when I took 5s or 25, and hence this is the answer. The answer is 28. Okay, and that's all. So I hope you got the idea what we're going to try to do. So let's just code the solution. So here we have our solution class, and in this class we have a find maximum XOR function. So let's first create a trie node. So struct trie node. So this trie node basically contains only two values. The first one is 0, the pointer to 0, and the second one is the pointer to 1. Basically each node contains either 0 or 1. So each node either points to a type of node which is 1 or a type of node which is 0. Fine. So we do not need an array of size 26 because we are just dealing with two types of characters, and that are zeros and ones. We can also use an array like this. We can also use something like trie node link 2. So this is again an array of two pointers. Basically we can store two pointers into this array, into this link array, which points to the most appropriate node, whether it is a node containing 0 or a node containing 1. Fine. So if corresponding to any node we have 0 as the non-empty pointer, then that means this node points to 0, otherwise this node points to 1. And like it may be the case that a particular node points to both of these numbers. Okay, so let's just start from the let's just build the insert function. How we're going to insert the words into the trie, or not the words, basically the integers. So let's see that. So let's create a void insert function. So it takes in the root node and it basically takes the number which I want to insert. Now just take a current pointer, initialize it with root. It will be used to insert the number. So let's iterate from the last bit, which is 31st bit, and move till the first bit and check, just extract the bit which is 1 left shift I and 1, and then check if this bit is 1. If this bit is 0, if it is not 0, we have two cases. So if this bit is 0, then what does that mean? That means we're gonna what does that mean? If we have this bit as 0, that means the bit at the ith position is 0. That means we create a new node. So create a try node. Let's call it new node, new try node. And for this current 0, I'm gonna put this node, new node. Okay, and move to the next node. Fine, so that's what I'm going to do here. So first here I also have to check if this current node does not point to any node, if the 0 component is equal to null pointer, if it does not already points to a node containing, if its 0 component does not points to any node. If it is the case, only in that case we create a new node and we point the 0 component for the current node to that new node and we move to that new node. Fine. Otherwise, just check if we have a one component for the fine. So in this fashion I will insert the current number n into the try, and I think that's all. Okay, so that's how the number n will be inserted into the try. So let's see how we can find the maximum of the numbers which we are checking for. So let's create a function which is maximize XOR. So this function starts from the root node, takes a number n and try to XOR it with the most appropriate number present in the try rooted at this root node. Okay, so create a current node which is initialize it with root and then try to start from the last bit, 31st bit, iterate over all of the bits, and for the ith bit extract the ith bit, that would be, now check if it is 0, otherwise if it is not 0, if it is 0 then what I'm gonna do is, so first initialize an answer which will store the final resultant XOR of the numbers. So if the ith bit is 0, then I will check if I have a child which points to 0 or 1 is not equal to null pointer. That means the current node contains a child which is 1. If it is the case, then that means club this ith bit with this bit. Okay, so add the corresponding value into the answer and move the current to that corresponding child. Fine. If it is not the case, if we do not have a 1 which points to the null pointer, in that case, if we do not have a 1 which points to the null pointer, then in that case we simply since we're gonna add 0 and it is not gonna change my answer anyway, just move to current 0. Fine. And do the same for the bit if it is 1. If it is 1, then if check if the current node contains a child which contains 0. So if it is not null pointer, then add this, the corresponding value into the answer and move this current to the next the corresponding child. Otherwise move it to the child which we have. Fine. So that's all I think we have to do. So in this fashion I will XOR my current number n with the most appropriate number present in the trie, and at the end return the answer. Okay. And here let's create the trie node. So let's first create the root node, trie node, which is the root node, and then what do we have here? We have answer variable, then we iterate over this nums. So iterate over this nums and just insert these numbers into the trie. So insert them into the trie. Then again iterate over these numbers and try to club the current number with the most appropriate number present in the trie. So call this function maximize XOR pass the root node and the current number, and at the end return the answer. So I think it's good. Let's see if it works or not. Okay, insert. Okay, it's C. Okay, let's call it root. Maximize XOR. Okay, it's giving wrong answer. I don't know why. Okay, that's the mistake I'm doing. I'm picking the ith bit from the number n. I need to pick the ith bit from the number n. Okay, so that was the problem in this code. So rest is good. So let's just submit it. Okay, so that's all. Let's discuss the time and space complexity. We can see that we are like inserting the numbers into the trie. We have the longest number is of size like 32 bits, and we have n such numbers. Okay, and that's the time complexity which I'm using for insertion. Then for like I'm also calling this maximum XOR function n times to get my answer, and that means we again have and the complexity for that function is Again, we are searching for the most appropriate path, and the maximum length of the path can be again of 32 length. So this is also 32 into n, giving me an overall time complexity of big of n, while the space complexity is like I'm storing how many nodes I'm storing, how many nodes I'm creating. Basically we have n numbers, and for every number we have 32 size allocated, and that's the space complexity. Fine. So that's all for this problem, and I hope you got something out of it and you learned something new. I will be solving a lot of such problems in the upcoming videos of the Trie series, and I hope to see you all in my next video.